Welcome everyone to the ultimate SketchUp AI Automation Masterclass. If you've been following our channel, you know that 3D modeling is undergoing a massive shift. Over the course of this video, we are completely rewriting how you approach 3D modeling. Instead of manually clicking, pushing, pulling, and aligning geometry for hours, you are about to learn how to turn AI agents like Gemini, ChatGPT, Codex, and Claude into your personal digital engineering team. By the end of this masterclass, you won't just be a 3D artist, you'll be directing AI to write custom, production-grade scripts that build complex architecture in a single second. Now, before we bring in the AI, let's look at the engine that makes all of this work inside SketchUp. To make this magic happen, we don't need expensive third-party plugins or complex software suites. Everything happens inside SketchUp's native engine using the Ruby Console.
You can access it directly by heading to Extensions, going down to Developer, and opening the Ruby Console. If you are on an older version of SketchUp, it might be right under your Window tab. If you don't see it, you can easily grab the extension developer tools straight from the SketchUp extension warehouse. This little console window is our direct bridge between AI-generated code and live SketchUp geometry.
Now, for this video, I'm using an upgraded Ruby Console plus plugin interface. It's a little bit more advanced than the default built-in one in SketchUp, giving us a cleaner layout for multi-line scripts and execution feedback. When it comes to generating the code itself, I'll primarily be using Codex to help us out, but you can absolutely use Claude, ChatGPT, or even Gemini for the coding part. As a quick rule of thumb, Claude and Codex are exceptionally strong when you need heavy, complex, multi-line architectural scripts, whereas ChatGPT is fantastic for shorter, quick execution formats.
To see how effortless this really is, let's start with a quick warm-up exercise. We'll jump over to ChatGPT and write a straightforward plain English request. Write a simple Ruby script for SketchUp that creates a 3D cube measuring 10 by 10 feet. Notice how I'm not using complex code terminology here, just standard architectural dimensions. In a matter of seconds, ChatGPT translates our design intent into a clean block of Ruby code. We simply copy that code, switch back into SketchUp, paste it straight into the Ruby console line, and hit enter. And just like that, a perfect 10 by 10 foot 3D cube generates right in our viewport. No push-pull tool, no dimension typing, zero manual steps. Now, creating a simple cube from scratch is great, but here is where the workflow becomes truly game-changing for real architectural projects. The Ruby console can interact dynamically with whatever geometry you select in your model.
Watch this. If I take the selection tool and click on the top face of our cube, it highlights in blue. The console immediately recognizes this active face. Now, if we execute a targeted code command, for example, calling a push-pull method set to 100 inches and hit enter, boom! That specific face extrudes upward by 100 inches instantly. This fundamental exercise proves two vital points. First, every single tool, operation, and transformation in SketchUp can be driven entirely by code. Second, you do not need to memorize or write a single line of this code yourself. We are going to let our AI agents write every script, debug every error, and handle all the math for us. Let's try this one more time. Choose the selection tool, and this time I'll select a different face of the cube. Again, typing in the push-pull command with 24 inches extrusion. Hit enter, and it gets extruded.
Now that we have our foundation set, we can clear out the canvas. Let's jump into segment 2, where we'll start building complex, multi-layered models. Now that we've mastered basic geometric execution, let's push this workflow to its absolute limit. The real question every architect asks is AI powerful enough to take a complete 2D CAD drawing and turn it into an accurate, fully dimensional 3D model? To test this, I'm bringing in a real-world 30 by 76-foot residential floor plan in AutoCAD. Before we feed this to our AI agent, we need to perform a quick cleanup. AI visual processing works best when there isn't unnecessary background noise. So we're going to turn off non-structural layers, things like furniture layouts, floor hatching, text dimensions, and even the staircase steps, which can sometimes confuse the edge detection logic. So our first step is a quick layer cleanup. We're going to freeze or turn off non-structural layers, furniture, plumbing fixtures, and even floor hatch patterns. We can also hide complex staircase steps, as those overlapping lines can sometimes trip up edge detection algorithms. Let's take a look at our print preview. Look at how clean and sharp that vector layout is now. All we have left are the core architectural elements, the 9-inch exterior load-bearing walls, the 4.5-inch interior partition walls, and the framed openings for doors and windows. This clean separation is what allows the AI to accurately calculate spatial offsets, wall intersections, and room bounding loops without hallucinating extra lines. Once your layout looks this crisp, export it directly as a clean PDF or a high-resolution image file. We'll save this to our desktop and get ready to head over to our AI workspace. Let's save this PDF.
Now, let me address an important technical distinction regarding which AI tool to use for this step. While ChatGPT and Gemini are fantastic for short scripts or localized geometry, a full house model requires hundreds of lines of hyper-specific Ruby API code. Standard conversational windows can hit output token limits or lose context mid-script. That is why, for full plan extrusions, we turn to specialized coding environments like Codex or Claude. These models excel at deep spatial reasoning, long-form code generation, and complex API logic. We upload our PDF plans straight into Codex and craft a clear, structured prompt. Analyze this floor plan drawing. Identify all structural walls, distinguishing between 9-inch main exterior walls and 4.5-inch interior partition walls. Set the overall wall height to 11 feet and create lintel openings for all doors and windows at a height of 8 feet. Write a comprehensive, production-ready SketchUp Ruby script that builds the complete 3D wall structure accurately from this drawing. Notice how specific we are with dimensions, heights, and structural hierarchies. We hit send, and Codex begins parsing the geometry. And here comes the absolute best part of this entire workflow,
the sit-back phase, because Codex is handling all the heavy cognitive lifting, calculating 2D vector coordinates, establishing wall offsets, mapping room intersections, and writing every line of Ruby logic. You literally have nothing to do for the next minute or two. This is your official window to sit back, relax, grab a cup of coffee, or check out that TikTok Jimmy sent you earlier. Or maybe rewatch that new Avengers Doomsday trailer that just dropped. By the way, guess who isn't returning in Avengers Doomsday? Yours truly. Turns out they completely passed on my audition. Unbelievable, right? Jokes aside, if you look back at the screen, look at what Codex is actually doing under the hood. It's not just drawing lines, it's building a programmable loop. It identifies the bounding box of each room, applies standard architectural wall thicknesses, calculates coordinate points, and frames out header beams over every single doorway and window opening. Look at the sheer volume of code generated here. It wrote over 300 lines of dense, highly structured Ruby logic. What's incredible about Codex is its self-correction pipeline. As it drafts, it continuously reviews its own code, checking for unclosed geometry loops, overlapping face normals, or syntax errors, and refines the script before presenting the final file. We can click on the generated file to expand it on the side. Notice how every section is neatly organized, starting with coordinate setup, moving into exterior wall extrusions, then interior partition loops, and finally subtracting geometry for door and window lintels. We can open this externally with Microsoft Word. We don't need to understand every line of this math.
All we need to do is select the entire block of code, hit Ctrl+C on our keyboard, and copy it to our clipboard. Now, for the moment of truth. We jump back into SketchUp, make sure our workspace is ready, and click right inside the Ruby console. We hit Ctrl+V to paste our 300+ line script into the console window. Now, take a look at the viewport. Press Enter and watch the magic happen. Boom! Look at that! In a single fraction of a second, the entire 30 by 76 foot CAD floor plan extrudes into a complete structured 3D model.
I mean, just take a look at this. It is honestly mind-blowing that a single press of the Enter key generated an entire multi-room structure straight out of a 2D PDF file. The speed alone is crazy, but let's do what any good architect does and check the real-world structural accuracy. We'll grab our tape measure tool and head over to the back of the house. Look at this rear boundary wall. It measures at exactly 4.5 inches. Now let's measure one of the primary side walls. Exactly 9 inches. And all door and window openings are cleanly framed out at 8 feet high. Codex didn't just extrude arbitrary shapes, it actually parsed our prompt instructions, recognized the wall hierarchy from the CAD vector thickness, and applied the exact structural dimensions we specified. What used to take an hour or more of manual line tracing, offsetting, measuring, and push-pulling just happened automatically with a single click. That is the true power of AI-driven architectural automation. Let's zoom out and verify the overall building footprint. If we snap our tape measure from the front boundary corner straight to the back, it comes out to an exact 35 by 76 feet. The outer envelope matches our original AutoCAD drawing down to the inch. Now, let's zoom in closer and inspect the interior wall junctions. You can see that the AI aligned most partition walls right along their center lines. It even picked up the room label text from our CAD layout and converted those into 3D text elements inside the space. Now, to be completely transparent, because no AI workflow is 100% flawless on the first pass, you might spot a few extra partition segments or slight misalignments where a wall corner didn't connect seamlessly. That happens because computer vision interprets overlapping vector lines as distinct structural nodes. But the fact that 90% of the complex wall massing, interior partitions, and rear yard window openings are already built is an unbelievable head start.
And here is the absolute best part about how Codex structured this script. It didn't dump raw, sticky geometry into our viewport. Everything it generated is cleanly organized into individual groups. The front yard is its own separate group, the main floor plate is isolated, and every wall partition is an independent component. This means if you need to make quick design tweaks, like stretching a wall segment that met at a center line, you don't have to rebuild anything. You just double-click into the group, grab your push-pull or scale tool, and snap the face directly to the adjacent edge in 2 seconds. Let's also double-check our vertical clearances. If we measure from the floor plate to the top of this door lintel opening, there it is, 8 feet short, exactly as we defined in our meta prompt.
If we take a closer look at the model surfaces, you'll notice that Codex went a step further and assigned distinct default materials to different functional components, separating wall surfaces, openings, and floor planes. Now, watch what happens when we head over to our display settings and toggle shadows on. Look at that! Instantly, the depth of those 8-foot window cutouts, the front courtyard, and the rear boundary walls pop off the screen. It creates a stunning, presentation-ready 3D massing that you can export for client previews right out of the box. This complete workflow proves that you don't need to spend hours manually tracing CAD plans line by line anymore. By setting up a clean vector layout and giving your AI agent the right dimensional parameters, you can go from a flat drawing to a fully grouped, measurable 3D model in a matter of seconds. Definitely try this out with one of your own project floor plans and see how much time it saves you. Before we tackle our next build, quick housekeeping tip. Always wipe your viewport and hit Purge Unused in Model Statistics so leftover geometry doesn't slow down SketchUp. Next up, an 11-story commercial tower. Since complex multi-level massing is too intricate for a simple request, we're using meta prompting. We'll ask Gemini to draft a structured developer prompt tailored specifically for Codex.
Here is our input. We want an 11-story building. We define crucial parameters, a 20-foot high ground floor, followed by 10 subsequent floors with a uniform 10-foot floor-to-floor height. We can also share a reference image of the architectural style we're aiming for. In the prompt text, you can be incredibly descriptive. Specify that it should have an active front porch space, a massive glass curtain wall glazing on the main facade, and define conventional window types for the side elevations. Gemini takes all that descriptive architectural text and converts it into a flawless logic map developer blueprint in seconds. We copy that structured developer blueprint directly from Gemini. Now we head back over to our code generation environment. I'm using Codex again for this. We upload our style reference image once more to ensure aesthetic consistency, paste the massive blueprint, and hit send.
Immediately, Codex gets to work parsing that blueprint and drafting the multi-layered structural loops. Since it's generating hundreds of lines of geometry arraying logic, this is the perfect moment for that TikTok break we keep talking about. And seriously, guys, make sure you leave me a comment while you're taking that break. I want to know which architecture-related pages, accounts, or design content you follow. Let me know what inspires you in this field and how architecture or interior design has shifted your perspective over the years you've been working or studying. I read every single comment you leave. All right, looking back at our screen, Codex has completed the script. It's a massive block of complex code. We copy the entire script, head back into SketchUp, paste it into the console, and take a deep breath before hitting enter. And boom, we immediately hit an API error. The console has filled with red text.
This is completely normal and often unavoidable when dealing with raw geometric intersections via code. Do not panic. We are not going to try and manually resolve this error. Instead, we copy the entire error message straight out of the console, paste it back into Codex, and instruct it to fix its own mistake.
Codex analyzes the error signature, identifies the faulty coordinate loop, and generates a new optimized script in seconds. Okay, let's copy this corrected code and see if it runs smoothly this time. We paste it into the console and hit enter. Wow, another error. This time it's a standard syntax issue. It's frustrating, sure, but we must stick with the workflow. We copy this second error message, head back into Codex, and ask it to try one more time. The generative process is iterative. It's often said that third time is the charmest, though I might have made that word up. Let's hope it's true for this algorithmic generation loop. Codex produces yet another updated version.
Let's hope this is the one. We copy the code, click inside the Ruby console, paste it, and press enter. Miraculously, the entire 11-story tower springs to life in our SketchUp workspace.
Just look at that initial massing! From the first look, this is superb. Every single visual hook from our Gemini meta prompt is present. The complex multi-level structure, the distinctive facade features, the color choices, everything feels architecturally grounded. Let's dive into the visual details and check the accuracy. If we grab our tape measure tool and snap the height of the ground floor, look at that, exactly 20 feet, as specified. We check the floor above it, perfect, a crisp 10-foot floor-to-floor clearance. We specified a distinctive ground floor active port space, and there it is, a bold massing protruding outwards on the ground plane, exactly as requested. But what is truly mind-blowing about this generative script is that it didn't just build the tower. It modeled a full set of trees arrayed across the front property line. Look at the landscaping detail. Those are amazing to say the least. It actually integrated landscaping into the architectural massing loop.
Moving up to the front facade, look at the logical breakdown. The main massing is structurally divided into 4 distinct vertical segments by these prominent structural columns that define the entire tower's envelope. The AI integrated hyper-accurate glazing logic, placing dynamic mullions to divide the main glass curtain wall bay by bay. And look here, it even modeled the recurring balconies at a perfect 3-foot structural offset from the main facade, complete with railings. If we orbit around to the side elevation, you can see it correctly switched from a massive glass facade to smaller conventional window geometry for the partition walls. This is all impressive, but as professional designers, we need efficient file management. Look what happens when we open our outliner. The entire model is impeccably organized. We don't just have random sticky geometry. Every single floor is its own clearly named group.
And notice this, floors 2 through 11 were generated not just as isolated groups, but as recurrent components. This is critical. If we want to change a window type or wall color on the 5th floor later, we don't need to rebuild 10 stories. We just edit the component and the entire tower updates instantly. The nomenclature is perfect, making this model incredibly easy to edit and manipulate. Let's take a final detailed look at the side windows and upper floor heights. Yes, they remain sharp conventional openings at a flawless 10-foot floor-to-floor height.
Usually, modeling a complex 11-story building massing with this level of detail, integrating balconies, column grids, curtain walls, and accurate floor heights, would take a 3D modeler at least an hour or more to construct manually. This just happened automatically in a matter of seconds. It is absolutely perfect for massing studies or conceptual design previews.
And because every floor is its own clean group, making corrections is simple. We can double-click inside, easily remove the few instances where a tree is clipping through the corner geometry, and finalize the presentation. We also get a separate geometry for the driveway and the main road outside the base, making it easy to drop this model into a larger urban context. By combining Gemini's meta-prompting with Codex's robust API logic, you can design complex architectural structures with complete ease.
Now, running custom scripts through the Ruby console is an absolute game changer for speed. But let's take a step back and look at the bigger picture. What if you don't want to open the console, copy code, and paste scripts every single time you start a new project? What if you could take this entire algorithmic generation process and lock it into SketchUp as a permanent native menu tool, or even turn it into an enterprise-grade extension that you can share with your team or sell online? Well, the good news is you can. And it's surprisingly easy to set up. All we need to do is take the full debug script we just generated, head back over to Gemini, and give it a simple wrapping instruction. We tell Gemini, wrap this entire script inside a safe, isolated Ruby namespace so it doesn't conflict with any other plugins, and register it as an official extension menu item called Tower Generator or 11-Story Tower under the Extensions tab.
Gemini handles the software architecture, setting up the exact API hook methods required by SketchUp's plugin system. In literally a few seconds, it hands back a fully packaged, enterprise-ready extension script. Let's test it out live. We copy the wrapped code, head back into SketchUp, where we've moved our previous building out of the way first. Click inside the Ruby console, paste the script, and hit Enter to register it. Now look up at our top menu bar under Extensions. Look at that. We now have a brand new native option called 11-Floor Tower Generator. If we click it, boom, the entire 11-story tower builds itself instantly on our empty origin point, right from a native menu click. It gets even better. You can actually ask Gemini to guide you in zipping this code into a standard .rbz file, which is the official extension format for SketchUp. This means you can install it on any machine, send it to your office colleagues, or build a proprietary suite of internal design tools for your firm. Now, if I open a completely fresh blank SketchUp file tomorrow, I don't need to touch AI or code at all. I just go to Extensions, Tower Generator, click once, and my 11-story massing is generated instantly.
Think about how you can leverage this in your own firm, whether it's parametric louvers, repetitive structural grids, complex site massings, or custom cabinetry. You can turn any repetitive design task into a one-click custom tool. This is how you transition from being just a 3D modeler to building your own automated architectural ecosystem. Now, let's take one more massive step forward into the realm of advanced parametric architecture. Generating a standard vertical building by code is already incredible. But what if we want true parametric variation, the kind of complex organic geometry that normally requires hours of grasshopper logic or expensive computational plugins? We head right back to Codex in our existing tower thread and give it a powerful modification prompt. We tell it, take our complete 11-story tower script and update the floor plate logic.
We want each upper floor to apply a progressive 15-degree rotation from the floor below it around the z-axis, creating a dramatic, twisting parametric tower. And here is a crucial tip for long-form scripting. Always explicitly instruct Codex to output the complete script rather than just a partial code snippet. This ensures you can copy and execute the whole thing in one seamless step without having to stitch code blocks together manually. Codex gets right to work modifying the floor plate transformation matrices and recalculating the structural column actors for each rotated tier. Now, this generation takes a few seconds because of the complex geometric math, but don't go grabbing popcorn just yet. It won't take longer than a minute.
All right, Codex has generated the full script. We hit copy, switch to our SketchUp workspace, and start completely fresh. We'll open a brand new file, clear our canvas, and ensure our Ruby console is completely wiped and ready for a fresh code execution. Click inside the Ruby console, paste the new code, and press Enter. And look at that! Absolute magic happens yet again, but this one is truly wonderful. Right here on our workspace, a breathtaking, parametrically rotating tower rises in a fraction of a second, built entirely by pure automated code. The visual result is magnificent. Look at how each floor plate smoothly twists by 15 degrees, creating a fluid, spiraling silhouette. Honestly, it's mesmerizing to say the least. I swear, if I had access to this workflow back in college, I would have submitted this as my final thesis project in a heartbeat. It would have taken me 5 seconds to build. But sadly, my thesis days were a long time ago. Let's turn on the shadows and inspect the structural details. Look at how the sunlight catches those rotated glass curtain walls and angled corner balconies. Every single feature from our original prompt remains completely intact. The 20-foot ground floor, the 8-foot door lintels, the column grids, and the glazing, except now it's mapped across a complex spiraling parametric axis.
This is the ultimate proof of what AI-driven automation brings to your design workflow. Limitless structural experimentation at the speed of thought. Now that we've mastered parametric geometry and extension building, let's look at another game-changing workflow, the material switcher. As designers, we spend hours manually opening the material tray, selecting faces, sampling textures, and tweaking colors one by one just to test different visual palettes. What if you could swap the entire color scheme of a massive 11-story complex in literally one click? We jump back into Gemini and ask it to write a lightweight Ruby script that target replaces model materials. We tell it to apply a sleek, darker palette where the concrete becomes a moody, dark charcoal tone and the glass tint shifts to complement those deep, modern architectural shadows. We copy the script, paste it into our Ruby console, and hit Enter. And look at that! The entire building's aesthetic switches instantly. Look at how seamlessly the darker concrete tones and glass tints balance each other out. Now, under the hood of this script, the logic is super straightforward. It's just reading and reassigning simple RGB values for each material group. To demonstrate how flexible this is, let's ask Gemini to generate a completely contrasting, vibrant color scheme. We tell it to build a neon-inspired palette with deep purples, hot pinks, and sky blues. Gemini gives us the code, and if you look closely at the lines before running it, you can actually see the exact RGB numbers established for glass, concrete, and pavers. Let's paste this into our Ruby console and hit Enter. Look at that shift! It's an energetic, almost neon synthwave visual direction. Hot pink accents, sky blue glazing, and dark purple massing. It proves how radically you can change the emotional feel of a massing study in a single second. Now, you don't even need to go back to Gemini every time you want to tweak a shade. You can easily edit the script manually right inside the Ruby console. Watch this. If we take the vibrant script we just ran, locate the concrete material variable, and manually swap out those purple RGB values for a custom matte charcoal setting, we hit Enter, and boom! The main structural walls update instantly to our exact custom shade. Let's switch on our shadows to see how these newly assigned materials react to the sunlight. Look at that depth. The crisp shadow lines against the custom glass tint and refined concrete tones make the whole model look like an ArchViz render right inside the native viewport.
And here is the absolute best part about building a material switcher script. It isn't locked to just one model. This script targets global material definitions inside SketchUp. So, if we open a completely different project, like the straight vertical 11-story tower we built earlier, we can open our Ruby console, paste that exact same material switcher code, and hit Enter. And boom! The original tower immediately inherits the brand new material palette in a split second. Whether you ask Gemini to follow a strict client brand palette or manually tweak the RGB values yourself, this simple automation loop saves you hours of tedious texture mapping across every single project in your studio. And that brings us to the end of this masterclass. I hope you guys learned a ton from this complete AI automation workflow, from turning flat 2D CAD plans into structured 3D models, to building custom SketchUp extensions, parametric towers, and automated material switchers in a single click. Now, I want to hear from you. Drop a comment down below and let me know what crazy architectural concept, script, or workflow you want us to tackle next. If you loved this video, make sure to check out our previous tutorials on modeling by code in SketchUp, or dive into our full playlists on house modeling, parametric design, and Photoshop for architects. And if you want to take your AI visual renders even further, don't miss our dedicated Comfy UI playlist, where we break down step-by-step setups for advanced architectural and interior design workflows. We have a lot more mind-blowing automation content dropping soon, so if you haven't already, hit that subscribe button and turn on the notification bell so you never miss an upload. Thank you so much for watching. Keep experimenting, and I'll see you next time with something new and wonderful.